In this section, we will explore, analyze, manipulate and reshape data using Pandas. We'll also see how to deal with missing data in datasets. In this section, you will get familiar with exploring and analyzing a dataset using Pandas. You will get familiar with data frame, Pandas data structure for tabular data. You will learn how to view and explore the imported dataset using Pandas inbuilt method. You will learn how to handle missing data in a dataset using Pandas. You will learn how to manipulate and reshape a real-world dataset. You will also get familiar with analyzing a dataset and answering analytical and statistical questions using Pandas. In the current video, we will start with importing a dataset, explore the dataset, and do some EDA on it. We will demo the code in a Jupyter notebook. We will start with importing Pandas and NumPy module. Then we will read our dataset into a Pandas data frame. The dataset we are using is a CSV file which has the loan data from the lending club. We are using a subset of the data for this demo purpose. However, you could download the complete data from their website. Now we have read our data, let's start exploring it. Pandas has lots of methods and attributes which we can use to do this EDA or exploratory data analysis. For example, to look for how many rows and columns are there, we will call the shape attribute. Here we find out that we have 1000 records or rows and 9 columns in the dataset. We can look at the column names by using columns attribute. The columns we have are amount requested, application date, loan title, risk score, debt to income ratio, zip code, state, employment length, policy code. Note that these columns were read by Pandas from the first line of the CSV and automatically assigned as column names and not as another record to the data frame. Let's print few rows from top of the data frame we just created. You could print out the whole data frame here, but you might want to avoid that in case the dataset you have imported is very large. We can also look at what are the data types of the columns. Pandas marks any columns other than numeric, int or float as object type. So even the columns which have string or text are also marked as object as shown here. The real-world datasets are not clean or very complete. Lots of them missing values. We can take a look at that by using count method. It will show the non-missing record numbers for each column. We'll take a look at how to handle missing data in a later video in this section. We can also look at some stats for the data by using describe method. It will print out the count, mean, standard deviation, minimum, maximum, and 25, 50 and 75 percentiles for each column. However, it will do that only for the columns which are of numeric data type, either int or float. We can also use describe method on single columns too. We can do this even for non-numeric columns. For example, here we can do it for state column. Here it shows that there are 49 unique records for states and Florida is the most frequent in our dataset. We can even see these unique records by calling unique. Let's look at another column. For example, application date. It shows that we have 1000 records in application date, but they all have only one date value, that is Jan 1st, 2017. Let's call unique to confirm. Since the data we took was from top of the file, seems like all records we have are from a single date. We can also group by the records on a certain column's unique value. For example, we can find out how many records are there for each state. We can even sort the results. We see that Vermont and Idaho has only one record each. By default, it's in ascending order. However, we can sort it by descending order too. We see that California, Texas, New York and Florida have the highest records, with Florida being the highest of them all. In this video, We imported a dataset, explored that dataset, and performed some EDA on it.